class. So today we're going to be talking about more triangle proofs. Let's try to look at this one together. So first, MN and MQ are congruent. MN and MQ are congruent right here. These two line segments. And SN, which is this small portion, is also congruent to SQ. And angle 1 is 90-degree angle, right over here. Now, what we want to prove at the end is the SQ is perpendicular to QM. That means we want to prove that this is a right angle also. That means somehow we have to show that these two angles must be congruent. In order for us to do that, let's reason one thing out. We have two conditions for the triangles that are congruent already. Wait a minute. This can be the third. So through SSS, we should be able to prove these two triangles must be congruent, and which allows us to say angle 1 is congruent and this green angle. Then by cpctc, and we should be able to finish the final statement. Let us try to write them together. So first, here is the statement, here's the reason. Now, first, let us assume that we put down this given over here just to save time. And first one is given. Now, but one thing that we reasoned out right after that is MS. Line segment MS was congruent to line segment MS. And that was a reflexive property. Now, then we were able to prove the triangle MSQ is congruent to triangle MSN by SSS. Postulate. Now, then statement number 4, then we get to realize that angle 1 is congruent to angle MQS. The reasoning here will be cpctc. Now, statement number 5, then from then on, we get to say an angle MQS is a right angle. And the reasoning behind that would have been a congruent angle to a right angle must be right also. Number 6. Now then, since we realize that this green angle is right angle, then we can say that the line segment SQ must be perpendicular to QM. And then the reasoning would have been simply perpendicular lines are formed by right angle or right angles. Alright, so that's it. That was number 1. Let's move on to number 2. So let us write down the givens. AB is congruent to AC. So here, we're going to write down AB, the entire line segment is congruent to entire line segment. Now, CD is perpendicular to AB. That means we should have a right angle over here. So as another right angle right over here. Now, but somehow we want to prove that line segment CE, this bottom line segment must be congruent to this one. Now, when I mark the bottom one, then that also implies that the upper one is a right angle too. Now, how are we going to do that? One way which we can do proving the bottom triangles are congruent. We can definitely do that too. In order for us to prove that bottom triangles are congruent, we have one angle, and since the big triangle is a isosceles triangle, we must say that this bottom angle, ACB, and then ABC also must be congruent, two angles, and this can be reflexive, third condition. And then after that, we can just simply say the green parcha cpctc. All right, then let's get started. So here's statements, and then the regions. First, we're going to assume that all these givens are right over here. Number two, we realize that triangle ABC is an isosceles triangle. Now, why? Because of the definition of an isosceles triangle, meaning when two sides in a triangle are congruent, the triangle is isosceles. Now, number three. Then we realize that angle ABC must be congruent to angle ACB. Why? In an isosceles triangle, two angles opposite to congruent sides are congruent. Now, also you could just simply write down two base angles in an isosceles triangles are congruent also. All right. Then number four, we can say about these two parts, the right angles, angle CEB and angle BDC. BDC are right angles. Now, number for the reasoning is perpendicular lines form right angles. Number five, then we can say angle CEB must be congruent to angle BDC. Now reasoning here becomes all right angles are congruent. Then number 6 here, then one more thing that which you can write is CB is perpendicular, congruent to CB. Reasoning number 6 will be reflexive. Now number 7, then we can say triangle CEB must be congruent to triangle BDC, and the reasoning behind there will be two angles and a side. So we have angle, angle, side. Now, step number 8, then we can say CE must be congruent to BD. The reasoning, yes, it'll be CP, CT, C. All right, so that's it for this. Let's go for the next next question. Here, first we gotta have AB is congruent to the small line segment is congruent to BC, and then EBC, which is this angle, is congruent to this angle. All right. Now, then we want to prove that the big triangle AD is an isosceles triangle. In order for us to prove that, what we actually need to prove is this line segment is congruent to this line segment. Then, it looks like what we can do, among a couple different ways, we can simply prove that this small thin triangles on the outside must be congruent to each other. The one way which we can do that is, since these two angles are congruent, we will realize that the supplementary angles are congruent. And then we can also say that since these two angles are congruent, EBC must be an isosceles, which tells you that this line segment must be congruent to this line segment. Then by side angle side from both sides, you will realize that these two triangles are congruent, which allows us to say these two sides being congruent, which leads to final conclusion of the triangle being isosceles. All right, so let us write this one up together. Statement and regions. So first one, we're going to assume that all the givens, once again, are written on the first part. Number 2. Now, then we realized the triangle EBC is an isosceles triangle. Now, the reasoning behind that, of course, is when two angles are congruent, it is an isosceles triangle. Now, statement number 3, because of that, I guess we can say EB must be congruent to EC. The reasoning is in an isosceles triangle, two sides opposite to congruent angles are congruent. Now, number 4. We also talked about angle ABE. So what we should say is technically angle ABE and angle DCE are supplementary to original angle that was given, EBC, and angle ECB. And then the reasoning would have been linear pairs, meaning they makes up a straight line. Number 5. Then we can say angle ABE is congruent to angle DCE. And the reasoning behind that would have been supplementary congruent angles are congruent. Now, number 6. It seems like we have all the conditions now to say those two triangles are congruent. Triangle ABE is congruent to triangle DCE. Now, number 6 is because of side angle side. Now, number 7, then we can say line segment AE is congruent to line segment DE. And the reasoning would be cpctc. Then the last statement can prove that the triangle, big triangle, would be isosceles. Because simply two sides are congruent in a triangle. Basically, we can call this one as definition of an isosceles triangle. All right. So there it goes. Now let's move on to the next question. So here we have PQ is congruent to DE. PB, which is this whole side, is congruent to AE, which is the other whole side. It's the overlapping portion. Now QA is perpendicular to PE, which gives us right angle. So is this one by the fourth condition. Now, then what we want to prove is that angle D is congruent to angle Q. Now, one thing that we get to realize is this: because AB is reflexive here, then this portion PA must be congruent to BE by the subtraction postulate, taking away the same portion. Then guess what? We realize that hypotenuse length. By that theorem, we get to realize these two triangles are congruent. Hence, making these triangles to be also congruent. Let's write them out. This can be statement and this can be reasonings. The first one. After all those givens are written, number two. Let's talk about the portions where we reason things out. Let's start with the right angle. Here, angle PAQ and angle DBE. Those are right angles. Now, of course, the reasoning is perpendicular lines form right angles. Now, statement number three, then we get to realize that these two angles are in fact not only they are right angles, but also they are congruent to each other. Now, the reason behind it is because, as you mentioned, all right angles are congruent. Number four, then we can say AB is also congruent to AB, which is itself, and that's reflexive. Now, statement number five, then we can say PA is congruent to PE. There will be by subtraction postulate. Now, number six. Then, yes, we are ready to say a triangle PQA and triangle DEB are congruent. Number six, the reasoning would be HL, hypotenuse line. Then number seven, then we can say angle D must be congruent to angle Q. And the reasoning here will be CP, CT, C. All right. So with that, we finished up to 4 questions, number 1 through 4. All right. I'm going to continue this solution from the second video. All right. Have a nice day, guys. See you later.